In match problem 2, we're considering an investment of $5,000 into a 4-year CD that earns 5.61% interest compounding continuously. We want to graph the amount in the account as a function of time for a period of 4 years. So one approach to that is to use the y equals screen on your calculator, plug in the function, and graph it. But what this question is a little bit more asking is, at the end of each year, what value are we going to have? There are a couple different ways to get that, and we'll look at both of those. So let's start off with just constructing our continuously compounded interest formula. So $5,000 invested at a rate of 0.0561 for T years. So essentially what we're interested in is a table of values that would give us the amount after time t for 0, 1, 2, 3, and 4 years. So we want these corresponding values. The long approach to this would be to evaluate this function 5 different times, plugging in 0, 1, 2, 3, or 4 for t. So let's take a look at a couple of quicker methods so that we don't have to go through that process that's really just a little repetitive. So our original function, we can go ahead and enter in our y equals screen. So 5,000 times e to the 0.0561. And then for a variable, we're always going to press this xt theta n. We just need some variable there. And close our parentheses. So one method is to go to the graph for our function, and then we could trace along that graph to find the corresponding values. Another method is to take a look at a table. So the first thing we're going to do is press the second key and then the window key to access this table set menu. So by default, your table start should be set to 0, and delta table should be set to 1. So basically our x values are going to start at 0 and increase by intervals of 1. So if we wanted to jump by intervals of 5, we would change that to 5. If we wanted to jump to every other year, we could change that to 2. If these are both set to auto, then our table is going to fill out automatically for us. The other option would be to set this to ask, in which case we would type in the individual x values that we're interested in. So the quicker way in this case is to set that to auto, and then we'll press the second key and then table. And what we have is an automatically generated table giving us an x value of 0, 1, 2, 3, 4, and this is going to keep going, and giving us those corresponding y values. So now if we were sketching by hand, we could plot the point 0, 5,000, 1, 5,288.5, and so on. So the other method that I mentioned, this method is nice because it gives you all that information about as quickly as possible. There's really not a faster method with the calculator to get that. We can also just press the graph button and take a look at the graph for this function. Now, right now my Windows settings are incorrect. So this only looks like x is going from -5 to 5. Y is probably going from -5 to 5. So I can't actually see the graph. So the first thing we'll need to do is change those Windows settings and make our y minimum, let's say like 4,800, since I know we're starting with 5,000, and make our maximum value 8,000. Just so I know it's big enough that at the end of this 4-year period, that will still be within the range. And we'll press graph again, and now we should actually be able to see our function. So this is the graph of our continuously compounded interest formula. So what we can do from this screen now is type in different values for x. So for instance, if we want to know how much is in our account after 3 years, we could type 3. And actually, you know what? Never mind, that didn't work. That normally works on my regular calculator. Oh, because what we need to do first is select trace. So we need to be in that trace mode so that we can move along the graph. And now we can type in a specific value for x. So in this case, after x equals 3 years, we would find that we have $5,916.46. So $5,916.46. So the graphing method has a few drawbacks. We have to make sure the window is set correctly. Then we'd have to type in each of those different values. Versus if we have that table set up, we have all of the different results that we need very quickly accessible. And again, if we go into that table set menu, we could change the starting value, we could change the table value, or alternatively, we could just set this to ask what that independent variable should be. So now it's not going to generate a table for us automatically. It's just going to let us type in different values for x. So even though the problem's not asking for it, if we wanted to figure out what's happening after 10 years, 12 years, and then jump to 20 years, so there's no specific pattern to those x values, now I can just type in those values and get the corresponding y value for each of those.